October 25, 1999. Somewhere over Missouri, two Air Force F-16s pull alongside a Learjet 35. Their orders are simple: get visual. Find out why a private jet bound for Dallas has missed its turn, climbed past its assigned altitude, and started cruising in a straight northwest line, refusing to answer the radio. The fighter pilots get within a few hundred feet. They look through the windows and they see nothing. The glass is opaque white. The cockpit has frozen from the inside. Inside that jet are 6 people. One of them, 4 months earlier, sank a 15-foot putt to win the US Open. Payne Stewart. They are already dead, have been for hours. The autopilot doesn't know that. The autopilot keeps flying for another 3 hours, until the fuel runs out and the jet spirals into a field in South Dakota, leaving a crater 42 feet long. 6 people died at 39,000 feet because of something invisible, something the cabin couldn't hold. So here is the question almost nobody asks when they board a plane. You sit down, you order a ginger ale. The captain announces you'll be cruising at 36,000 feet. Why that number? Because here is what is strange. The Boeing 787 you flew to Tokyo, its certified ceiling is 43,100 feet. A Gulfstream G650 will do 51,000. Concorde routinely cruised at 60,000. The U-2 spy plane flew above 70,000. And on the 28th of July, 1976, a pilot named Captain Robert Helt climbed an SR-71 Blackbird to 85,069 feet. So why, when humanity has built machines that fly twice as high, does every commercial airliner you've ever boarded refuse to climb past 40,000 feet? The answer is not one thing. It's 4. 4 ruthless limits, each one indifferent to engineering ambition, all stacked on top of each other at the same altitude. And the last one is so thin, so sharp, and so unforgiving that test pilots have a name for it. They call it the coffin corner. By the end of this video, you'll understand why your aircraft is afraid of it, and why one airliner once defied all 4 limits at the same time, and why it was the most beautiful machine ever built. Start with the obvious problem. Outside, at 40,000 feet, the air pressure is about 2.7 pounds per square inch. Inside the cabin, where you are watching a movie, it's nearly 11. That difference doesn't disappear, it becomes a load. An outward squeezing pressure on every rivet, every window frame, every square inch of skin, constantly, for every hour of every flight. Engineers call it differential pressure. Multiply it across the surface of a 737, roughly 20,000 square feet of skin, and you get millions of pounds of force trying to burst your tube of aluminum like a balloon. Every flight, every climb, every landing. Now, aircraft are designed for this, of course. Pressure vessels are old engineering. Submarines deal with worse, but airplanes don't fail from one bad load. They fail from the same load, applied tens of thousands of times. They fail on a clock that doesn't stop. And the world first learned what that does to metal on January 10, 1954. A British Overseas Airways de Havilland Comet, registration GALYP, taxis out of Rome's Ciampino Airport. 35 souls on board. The Comet is the most futuristic airplane on Earth. The first jet airliner in commercial service. Pressurized, sleek, square-windowed, glamorous. 20 minutes after takeoff, climbing through 26,000 feet over the island of Elba, it explodes. No survivors, no mayday. 3 months later, another comet does the same thing. Same altitude band, no warning. Britain grounds the entire fleet. The investigators at the Royal Aircraft Establishment do something nobody has tried before. They take a comet, named GALYU, and they sink it into a giant water tank at Farnborough. They pump it up, they let it down, they pump it up again. Cycle after cycle, simulating real flights. After 3,057 cycles, about half what the comet was supposed to last, the fuselage bursts open. The fracture starts at a tiny rivet hole near a square cutout in the cabin roof. The metal had remembered every single pressurization, and one day, with no warning, it gave up. This is the moment the aviation industry learns the word that will define every cabin altitude limit forever after: fatigue. Round windows replace square ones. Drilled rivets replace punched ones. The fuselage becomes a pressure vessel with a designed lifespan, a known number of cycles after which it must be inspected, retired, or scrapped. But fatigue is patient. Fast forward to April 28, 1988. Aloha Airlines Flight 243, a Boeing 737-200, climbing through 24,000 feet between Hilo and Honolulu. A passenger had noticed a hairline crack in the fuselage during boarding, said nothing. At 24,000 feet, 18 feet of upper fuselage, the entire roof above first class peels off in a single second. A flight attendant named Clarabelle Lansing, 58 years old, 37 years with the airline, standing near row 5 collecting cups, is gone. Out the side of the airplane. Her body is never found. That specific 737 had flown 89,680 cycles, nearly twice what its engineers said it could survive. The same lesson taught a second time, in blood. So the first wall is this: the higher you cruise, the harder pressure pushes outward, the faster the airframe ages. That is why the 787 and the A350, made of carbon fiber composite, can hold a richer cabin pressure than aluminum jets. Composites don't fatigue the same way. But notice what hasn't changed. None of these aircraft go any higher, because the second wall isn't the metal, it's you. Here is a number they don't print on the safety card. If, right now, your airliner cruising at 40,000 feet were to lose pressure, the time you would have to put on the dangling yellow mask before you stopped being able to think is less than 30 seconds. Make it explosive decompression, the kind where the door simply leaves and that drops to 15. Climb to 50,000 feet, where Concorde flew, and a conditioned athlete gets 10. This is called time of useful consciousness. It is the gentlest phrase in aviation and the cruelest. To understand what 15 seconds actually feels like, go to August 14, 2005, Larnaca International Airport, Cyprus. Boeing 737-300. The captain is Hans-Jürgen Merten, 59, German, 16,900 flight hours. His first officer is Pampos Charalambous, 51 Cypriot. In the back, 4 cabin crew. One of them is Andreas Prodromou, 25 years old, holding a private commercial pilot's license, in love with another flight attendant on the same flight, a woman named Harris. They had planned to marry. The night before, a ground engineer ran a routine pressurization leak check. He flipped one switch from auto to manual. When he was done, he forgot to flip it back. 3 checklists later, 3 opportunities for 2 pilots to glance at one panel. They don't see it. Flight 522 takes off at 0907. Climbs out over the Mediterranean. The cabin doesn't pressurize. At 12,000 feet, the cabin altitude warning horn screams. Captain Merten, already hypoxic, looks at the horn and reaches a wrong conclusion. He thinks it's a takeoff configuration warning, a horn that, by a piece of staggering Boeing design cruelty, has the identical tone. He calls Helios operations on the radio. He asks about the cooling fans. His voice slurs. The ground engineer on the line, the same one who left the switch in manual, asks the question that would have saved 121 lives. Can you confirm the pressurization panel is set to auto? There is no answer. For the next 2 hours and 45 minutes, the 737 flies itself, climbs to its programmed cruise altitude, levels off, reaches Athens, enters a holding pattern, just keeps holding. At 11:23, 2 Greek Air Force F-16s intercept the aircraft over the island of Kea. The fighter pilots can see the whole cabin. Oxygen masks are dangling. Some passengers are slumped, some are not wearing them. The first officer is collapsed forward over his controls. The captain's seat is empty, and then, at 11:49, something extraordinary happens. A man enters the cockpit. He sits in the captain's chair. He puts on the headphones. It is Andreas Prodromou, the flight attendant. He had reached the rear galley where the portable oxygen bottles were stowed. 3 of them, valves later found open, had been used. he had stayed conscious where everyone else failed. He sends 2 Mayday calls. Mayday, Mayday, Helios Airways Flight 522, Athens. The radio is still tuned to Larnaca. Nobody hears him. Seconds later, the left engine flames out. Fuel exhaustion. Andreas does the only thing left to do. He banks the aircraft away from the city. The F-16 pilots later report that the way the 737 hits the ground, wings level, controlled, looked like a man trying to give the people below him a chance to live. 121 people die at Grammatico, Greece. This is why the FAA wrote a regulation that, more than any other single sentence on Earth, is the reason your flight stops at 40,000 feet. After any decompression, the cabin altitude cannot exceed 25,000 feet for more than 2 minutes, and cannot ever, for any duration, exceed 40,000 feet. In plain English, before you certify an airliner to cruise at a given altitude, you have to prove in a flight test, with engineers timing you on a stopwatch, that the crew can dive that aircraft back down to breathable air fast enough that nobody dies. Above 40,000 feet, the math stops working. The atmosphere is too thin. The descent takes too long. The humans run out of oxygen before the metal runs out of altitude. That is why your 787 is technically certified to 43,000 feet, and operationally almost never goes there. But there is still one wall left, the worst one. Up to now, we've talked about the airplane's enemies as if they were outside. Pressure, physiology, regulation. Now we have to talk about the enemy that lives inside the laws of physics. As you climb, the air thins, and 2 strange things happen to a wing in thin air in opposite directions. 1. The wing has to move faster. Its true airspeed has to rise, just to generate the same lift. So stall speed climbs with altitude. 2. The speed of sound drops because sound moves slower in cold, thin air. So the maximum speed at which the air over the wing remains subsonic falls with altitude. Stall climbs, Mach falls, the scissors close. Keep climbing, and you reach an altitude where they meet, where the aircraft cannot fly slower without stalling, and cannot fly faster without the shock wave on its wing tearing the lift out from under it. Pilots call it the coffin corner. On the U-2 spy plane, designed in 1955, the gap between stall and Mach buffet at 70,000 feet was as narrow as 10 knots. On some early variants, 5. The margin is so tight that the autopilot does the flying. The pilot wears a spacesuit, and if the U-2 enters a gentle turn at altitude, the inside wing slows down and the outside wing speeds up. Both can exceed their limits at the same instant. Stall and overspeed the same second. This is why airliners are certified to maintain at least 0.3 G of maneuvering margin at maximum altitude. At 41,000 feet in a fully loaded A320, that margin is already tight. A sudden updraft, a moment of distraction, a clear air gust, and you are in the corner. At 45,000, you do not have room. At 50,000, you do not have a plane. Even when you build an aircraft that defeats the corner finds you. On May 1st, 1960, a CIA pilot named Francis Gary Powers was cruising his U-2 at 70,000 feet over the Soviet Union, trusting altitude to protect him. A Soviet missile detonated behind his aircraft at the absolute edge of its reach. The shockwave was enough. The myth that altitude was untouchable broke with him. So only 2 civilian aircraft in history have ever routinely cruised above 55,000 feet. Concorde. The Soviet Tupolev 144, both supersonic. Both passed through the coffin corner on the way up, and then passed out the other side. Above the speed of sound, the whole envelope reopens. They cheated the corner by going around it, which is why they burned 4 times the fuel of a 747. Which is why, despite being the most beautiful aircraft ever built, they no longer fly. So go back to the question. Why 40,000 feet? Not because of one wall, because of 4 walls all stacked at the same altitude, each one reinforcing the next. The structure wall. Push higher, and the differential pressure rises. Fatigue cycles shorten, and somewhere over an ocean, a forgotten rivet decides it is done. Aloha 243. Comet GALYP. The physiology wall. Push higher, and the seconds you have to save yourself after a leak collapse below the time a human being needs to notice that something is wrong. Helios 522. The regulation wall. Push higher, and you simply cannot prove on a stopwatch that your crew could dive a full cabin back down to breathable air fast enough. So the FAA says no. The aerodynamic wall. Push higher, and the very physics of the wing collapse inward, until the only safe airspeed is no airspeed at all. And then, stacked behind those four, a fifth wall that nobody talks about, but that decides every single flight you take: the economics. The most efficient altitude for a fully loaded 777 is not its 43,000-foot ceiling, it's closer to 36. So airlines step climb 2,000 feet at a time, every couple of hours, chasing the moving optimum as fuel burns off and the airplane gets lighter. A 737-400 going from flight level 320 to flight level 360 saves about 100 kilograms of fuel per hour. Multiply that by 400,000 commercial flights per day, and you understand why no airline with a balance sheet is asking for permission to fly higher. The plane can go up, the accountants won't let it. Stack those 5 walls: structure, physiology, regulation, aerodynamics, economics. 40,000 feet stops being a number on a chart. It becomes the line where the laws of materials, of biology, of bureaucracy, of physics, and of capitalism all happen to intersect. The invisible ceiling of civil aviation. Now look at that Learjet again, over Missouri in 1999. The jet had climbed past its assigned altitude to 39,000 feet. Right up against the stack. A pressurization leak, flagged in maintenance months earlier and never fully fixed, bled the cabin out during the climb. The pilots had at most 30 seconds to put on a mask. NTSB testing found that as little as 8 seconds without oxygen at 30,000 feet can erode cognitive function enough to make you stop trying. In a slow leak, you don't even feel it coming. The F-16 pilots could not save them. No one could. To save them, you would have to reach into the airplane and push the yoke forward. And the only people in position to do that were already gone. The cockpit was frozen because the bodies inside it were too cold to fog the glass. This, right here, 36,000 feet. This is the altitude humanity has decided is safe. Not because nature drew a line, but because decades ago, in a Farnborough water tank in 1954, in a cabin over Hilo in 1988, in a cockpit over Greece in 2005, in a frozen Learjet over the Midwest in 1999, we found out expensively where the lines actually are. Every line on every chart, in every flight deck, on every airliner above your head right now, was drawn over someone's coffin. So the airlines fly under the line. 40,000 feet isn't a law of nature. It is the altitude at which 4 laws of nature meet, and at which human beings, finally, stop trying to outrun any of them. But of course, one civilian aircraft did try. For 27 years, Concorde climbed straight through the coffin corner, stared down 4 walls, and cruised at twice the speed of sound at 60,000 feet. Its passengers sipped champagne above the curvature of the Earth. And then, one July afternoon in the year 2000, on a runway outside Paris, it caught fire. And the dream burned with it. If you want to know why no one has ever replaced it, and why we may never fly that high again, that's the next video.